Hi, everyone. Just a quick note. The episode you're about to listen to is from our partnership with ElixirConf Japan. You're going to hear a quick intro in Japanese from our friend Paige Finkelstein, who is a friend of the show and an Elixir developer that used to work here at SmartLogic. The episode continues in English from that introduction, so just keep your ears open. For our listeners in Japan, please check out the Japanese transcript put together by the ElixirConf Japan organizers. Okay, here's the show.
エレクサーウィザード道場のイベントにようこそ。この番組はエレクサーウィザードとElixirConf JP の特別なコラボレーションです。ページ・フィンクルスティンと申します。エレクサーエンジニアとエレクサーウィザードのポッドキャストの友達です。この番組はSmartLogic というバルチモアにあるカスタムのソフトウェアとアプリを作る会社でお送りします。今日は Now the Project のメンバー、フランク・ホンレント、ジャスティン・シニアック、コーノー・レグビー、そしてトード・レズデクと話しています。Now the Project のメンバーと対談として日本人、そして世界中の方々のエレクサーに関する質問に答えて回答をシェアしたいと思います。今日のエピソードは皆さんの好きなウィザードエリック・オストリッチとジャスタス・イーペンがホストします。この後、英語と日本語のテキストでリリースします。では、お楽しみにしてください。
Thank you so much, Paige. Welcome to the Elixir Wizards Dojo, a very special collaboration between the Elixir Wizards podcast and ElixirConf Japan. That was Paige Finkelstein, an Elixir developer in front of our show. This show is brought to you by SmartLogic, a web and mobile app development shop based in Baltimore, Maryland. And it's a very special episode because we're partnering with ElixirConf JP or ElixirConf Japan. Today, we will be talking with several members of the Nerves core team. Frank Hunleth, who's in the chat with us right now, Justin Schneck, who I assume will be joining us very shortly, Connor Rigby, and also Todd Rezadek. We have been receiving questions from the Elixir community in Japan and all around the world, and we'll be asking them these questions. We'll be asking these questions to our guests today. This episode will be hosted by your favorite wizards, Eric Ostrich, and myself, Justin Siepen. The show will be recorded and released in the coming weeks on the Elixir Wizards podcast with transcripts in both English and Japanese. Welcome to the show, everybody. Frank, glad to have you on.
Glad to be here.
Is this your first live stream, Frank?
I think it might be. Yeah, I think everything else has been recorded. So, yeah.
Welcome to your first live stream, Frank. And there's Justin's Schneck. How are you, Justin Schneck? Good. I was going to say the Justin's neck joke, but I feel like it's getting old.
Can everybody hear me okay?
Yeah, you sound pretty good. Your mic might be up above your ear.
Oh, I think I'm at this one.
Oh,
maybe.
No, you're on. You're on. I like this pattern you got going on behind you.
Thanks. A nice little. I needed some artwork to be able to freshen that wall up a little bit. Looking at the traditional color that I see most of us have, I don't know. We've got a little bit of variation, but it's a nice calming. And then that's the wake up, stay alert portion of this. Yeah.
Oh, that pattern is stimulating?
Mm-hmm.
Mm-hmm. Well, this is so exciting because you guys are like the Nerves Core Assemble. It's so exciting. Before we jump into like the questions that we've gotten from the Japanese Elixir community, just, want to kind of check in, see what you're bringing here today. How is everyone? Where are you calling us from?
You want to go first, Justin?
Sure. I'm feeling good today. Yeah, it's good. It's a little rainy here in Bethlehem, Pennsylvania, but we kind of needed this. This way, my outdoor robotic garden can take a break.
So the, what's it called? The robotic garden.
FarmBot?
Yeah. FarmBot. I was going to say like garden drone or something like that. But, so I was going to ask if it doesn't work in the rain. And then I was like, well, if it's just watering your plants, it probably doesn't need to work in the rain. Frank, what about you? How are you doing?
Doing well. So I'm calling in from just outside of Washington, D.C. in Maryland. I mean, holding up in my house, my neighborhood. Life is good, or at least as good as it could be.
Right. How often do you two get to do you guys ever meet in the middle?
We've driven to each other's houses. We're not too far away, but we have any plans to meet anytime soon at the moment, though.
Right.
Yeah.
Well, it's super glad to have you both on. We should also check in with Eric. How are you doing, Eric?
Currently dealing with extra white noise that I'm trying to turn off the AC, see if that's it. But yeah, doing good. Got my shirt from Todd last year, Frank, Justin, Connor, Greg.
Oh, that's great. I really want one of those. So we've got a number of questions and we will definitely get into them. I want to just give a little bit of context for the show. People might be asking like, whoa, like what is this Wizards ElixirConf Japan mashup? And we were reached out to by one of our favorite members of the community, Suzumu Yamazaki, also known as Zaki, who has spoken at many of the conferences and is just like a really good friend of the show. And he told us that we have got a lot of folks in the Japanese Wizards community that have, I think since you went out there last year, Justin, have been a little bit obsessed with nerves. And so they were asking if we could partner on a show and to promote ElixirConf Japan and to promote nerves and also to do a show that would be like transcribed to Japanese and just the whole thing. So it was very exciting for us. So we came up with this concept of the dojo. And so we've got Frank Hunleth and Justin Schneck here, and later we'll have a couple other guests, and we've got all these questions from the Japanese nerves community, and we'll start with some of the general questions. Really, we want to know at this point, because nerves has been around for a few years now, like how big has the platform gotten in terms of like usage, and do you have any idea? How would you even tell?
So first off, I mean, the Japanese Elixir community and their involvement in nerves, I think that as a mirror of this question in itself, to shine it on them, they have been so active and so excited towards building devices using Nerves Hub. There's a lot of activity from them that they want to be able to try to be able to explore more, help out more, and they're using it for ways to be able to do research and exploration towards new concepts and new ideas, and that's really exciting. So as far as the growth of the community, a lot of it is from people talking about projects they're working on, people experimenting with different things, and the vocal nature of, I guess, that excitement of the community. That's kind of like double-edged in a way, though, because as I'm sure Frank has experienced this as well, we've always talked about this in the past, like people who work on embedded projects at companies tend to speak less of those, like externally. They're usually quieter about that than they are about like what web projects they're working on, or if they have some VC thing that they're doing, like Silicon Valley startup-wise. People are less vocal in those cases.
Oh, yeah.
And so it's hard. Yeah, it's just so hard to shake out the production use cases.
Right. I think the sampling that I get is that there are some insanely good questions that, clearly someone has this thing deeply embedded. We have those on the Nerves Slack periodically where someone asks just this very interesting question that you'd never get to unless you had kind of an industrial usage. And I think we gather them from time to time. We've had talks where we've showcased a few of the companies that use Nerves and I've been okay with publicizing that. I think the Codebeam San Francisco, I showcased a few, like Snyder. We always talk about FarmBot because Connor always, that FarmBot's just a cool thing. They have lots of cool videos. But there's Rose Point that's been pretty actively promoting the little Nerve stuff and tugboats. Not stuff that you'd actually see in real life unless you go along some of the major waterways in the US, but still, it's there. Yeah. And then I guess we have some farming ones where we'll have some examples later on. But yeah.
Could you maybe dive into the FarmBot and farming applications? Just because I think that probably a lot of people in recent months have taken up gardening.
Yeah, FarmBot is a pretty cool device. It kind of actually blends in a little bit with some of the other questions. There's another question that we have as well that we get asked a lot.
And feel free to jump around. We don't really stick to the script very well, as you both know, I think.
But some of these things are really intertwined as far as being able to really show a practical use case of how some sort of facet of design might be implemented using Nerves, right? So FarmBot's an example of a situation where you have to do some motion control, and that's going to require some more hard real-time constraints. And with Nerves, our focus is mainly on, it's in embedded Linux, and inside of that system, we tend to be more of the soft real-time, especially with the state with the Erlang VM. We can discuss some more of that a little bit more later. But anyways, to satisfy the question that people have up front, which is I need to be able to kind of blend these environments. I need to be able to do some hard real-time stuff, like control some motors or something, get some good deadlines.
Okay. Can you define that for me, just as a totally naive person? What is soft versus hard real-time?
Sure. So modern computer, like general purpose computers, we have these general purpose operating CPUs and then operating systems built on top of it that allow us to be able to multitask and do several things at once. And in those cases, those have complex schedulers, which schedule all the work to be able to tell who has time to be able to do what events, like what processes get certain slices of the processor's time so that everybody can kind of get a fair share. But in those cases, you can't make guarantees on when deadlines are hit. So if you have some really high priority process that needs to get accomplished by a certain period of time, it's difficult when you have all of these other processes that are also fighting for the same pool. Frank's like looking like I'm butchering this one bad, but he's like, oh.
You're getting there. No, I'll help you out. Tiny minutes. I think that the core thing is just how severe the error is if you miss your deadline. Like if you have some task that you're trying to do, did you just destroy something completely and the product's totally broke? Well, then that's hard real time, more hard real time. But if you miss a deadline and it's like 1 out of 1,000 times or 1 out of 10 million times or whatever, and it's okay, your product survives, then, that's in the soft area.
So like, I guess with the example of FarmBot, can you maybe give me like a specific, like I'm trying to imagine like a FarmBot failing in such a way that it just totally bricks the device because of a hard real-time failure. Maybe it just like runs right off the tracks because it didn't know when to stop or something like that.
Well, in this case, it's that you need to pulse electricity to the motor to be able to tell it to move a certain amount so that you can ensure that when you told it to move a certain amount, that it moved that certain amount. So that kind of action to be able to control that motor in that case, to be able to at that point, get the accuracy desired is the reason for the need for the hard real-time component. And because FarmBot uses sort of an amalgamation of open source or publicly available products, such as Raspberry Pi and Arduino, from the easy to digest maker's perspective of things, through that lens, you can sort of see how you can piece components together so that they can excel in their own domains. And so in that case, the Arduino is being able to handle a lot of the movement control. And what it does is it's just essentially a processor that then exposes an API over an interface to the larger main processor that handles all of the things that would be more complex to do in Arduino, which would be like network I/O and uplinking things securely to the internet and communicating with cloud servers and stuff. And so like in that case, running nerves on the embedded Linux side of things excels in that domain because it can also monitor and make sure that the Arduino processor is doing its job. It can leverage and embrace that as part of its local domain as if you'd consider it a process, an OTP that can be supervised and monitored. And that's where it's excelling. It's that gateway. It's that uplink for nerves. And so that's why I say it kind of embraces some of these other questions. We get like, how do I do hard real-time stuff? Well, a common answer for us is that use case where, you'll sort of manage your hard real-time components as part of your umbrella underneath your nerves node and let the nerves device do what it excels at and acting as the edge device or the gateway device to be able to connect your local landscape of processors, if you will, microcontrollers, if you will, to the greater internet. And you can also go so far as to you can embed the firmware for your Arduino inside of the Raspberry Pi firmware that they push down. And that way you can manage both of them locally using one framework through Nerves Hub. Does that make sense? Was that too much of a spew? You've got that look, Jess. It's like, you're just like, how did we get here?
Well, Go ahead, Frank. I wanted to give Frank a minute.
So, it seems like a lot of these projects that you want to create some hardware for or something like that have like a little hard real-time component. And it's kind of nice to know that part just works really well. And there's a lot of knowledge and theory and experience on building hard real-time things up on microcontrollers. We really push that route where you look at your project or your device, you take out the hard real-time part, program in the microcontroller using known techniques, set up a communication channel to the bigger microprocessor that runs nerves, and then you do all this networking, business logic, all this stuff that you kind of have to do, but you don't really want to think about so hard about how it could mess up deadlines and stuff. You put it all there. Then, as Justin was saying, there's this kind of nice OTP supervision-ish infrastructure that you get through Erlang, and you can extend it to supervising that microcontroller, like rebooting it if it starts going haywire or something, or becoming irresponsive.
Yeah, I was going to ask if you're supervising the microcontroller, if you can like either like a Raspberry Pi powers the microcontroller or and then like just like switches the GPIO pins, or like how does that work?
Yeah, so usually you have like a wire, it's called a reset line. There are multiple ways of doing that, but you just toggle it and the thing reboots. This whole concept of turning things off and on again is pervasive everywhere. So
at all scales. I want to dive a little bit into the specific applications, because I think that probably people will find it really interesting, which is why it's one of the first questions that was asked. But FarmBot's open source. Did you guys help them put it together at all? To what degree?
I mean, they reuse a lot of Nerf stuff in it, so I guess I feel indirectly
Okay,
like
but
I
you
helped.
weren't.
But
you weren't like helping them like do that.
No,
right?
no.
Okay.
Well, I didn't. I think Justin, you contributed to the FarmBot project.
Yeah, I've worked to make some contributions and help out there as I can, but that was after they've already decided and make their choices to be able to use nerves. Connor was an advocate early on because of the complexities that they had in their system that they were maintaining for packaging before.
I'm looking at the GitHub right now. They've got the operating system that runs on the Raspberry Pi, which I assume is what is running nerves.
Yeah.
And then they've got the web app, which is made in TypeScript. I'm guessing that this is like, okay, so they didn't build, I guess, what you'd call like the control panel, like the user-facing control panel in Elixir. They built that in Node. Is that what that is?
The server language is a mashup of a bunch of different technologies. There might be some Elixir in there to be able to handle some high throughput loads or some queues maybe, but as far as the stack is concerned, a lot of the Elixir is driven on the device's end. And, this is common in IoT platforms. There's always the web component, and the beautiful part with Nerves and Elixirs on the device end of things is that it doesn't dictate what your web stack has to be. It can work with anything else.
Have you guys gotten to apply Nerves to any projects that you can talk about? I mean, like an open source project or personal projects?
Sure. I'll let Frank start because I can geek out on that subject for a while.
You have tons of open source projects. My projects are like little one-offs that, like Halloween decorations that I make turn like, I don't know if you remember, there's a time where it was popular to get all these dinosaurs or different bone, skeletons, and they would scream at you. So my kids and I, we thought it'd be fun to control one of those and have it harass the trick-or-treaters.
Wait, so you got one that already did that, and then you just like plugged it?
We got one, and then we gutted out the electronics and jammed in a Raspberry Pi and some other stuff. Oh,
that was one of my all-time favorite Frank projects. Yeah,
I like that you took an existing working one and then just was like, let's do it ourselves.
Well, I mean, the hard part about a lot of this stuff is a lot of the mechanicals and motors, and at least that's hard for me. The software part, it's a little bit easier.
So your kids think you're like Tony Stark.
Yeah, they really clearly do not. I have teenagers, so I've passed that phase.
It's funny, Eric, a friend of mine just recently said this quote to me. He goes, only an engineer would buy a product so they can spend twice as much money building their version instead of using the one that they bought. To reverse engineer one, right? Or, to gut it and do something else, yeah.
Wow, that's depressing right now.
So we've got Halloween. Scaring children is one application. Anything else that, Justin, you want to talk about one of your favorites?
Justin should talk about his. He has a bunch of cool
Justin
ones.
Makes one for every single keynote that he does. It's like a different demo.
Yeah, I try to put something together that's a fun use of it for any talks that I do. It's mainly because conference-driven development, I should say, like doing something in Nerves or like extending something in Nerves is always like, let's find something we want to build or some project or some even thing that we want to exercise. It may even been done before. It's just fun to be able to implement and get up and running and working and talk about it. But of those projects, one of which I have FarmBot outside, I have 2-farm deep water culture hydroponic system in my office that's controlled with Nerves. I'm growing.
I'm sorry, slow that down. We're one word at a time.
So I have
deep water.
I have two deep water culture hydroponic systems in my office.
Okay, yeah, one word at a time. What is a deep water hydroponic?
It's basically a 5-gallon vessel that the roots grow down into that contains a flowing nutrient solution that I change periodically.
And what are you growing?
I'm actually, the reason I'm growing, I'm growing Sichuan Chinese chili peppers to feed my Chinese cooking addiction because it's hard to get Chinese peppers right now. So,
wow, that's insane.
So I was able to germinate 2 plants I have outside, 2 plants I have inside, and I have one that's a rare one that I was able to, out of 100 seeds, finally get one to germinate. That's the Erjingtao peppers. And this is all because of Lance Halverson. He ruined me by showing me Sichuan Chinese cooking. As an aside, if you're interested in learning more, you can get Fuchsia Dunlop's book about the food of Sichuan, which contains many wonderful recipes. And
I've actually been to Sichuan.
It's really
hot pot, right? Is from there.
It's really the flavor, I would say of China. the mala flavor, that mouth numbing. It's like you got anesthesia or not anesthesia. What is it? Novocaine. It's like Novocaine. Yeah.
Or menthol, right?
Yeah. That one is a fun one that controls my lights and everything and timers. For professional installations, we've shipped nerves into industrial spaces where they're being added on as gateways to industrial PLCs for manufacturing facilities. We've also recently finished a project up where it's going to be used for smart energy sector to be able to power some energy grids or like some smart city stuff. We're working on a couple projects coming up. There's a couple consumer electronic devices that we're going to be launching that have nerves in them.
Can
One of which is a
okay.
Sure, yeah. One of which is a children's sleep clock. So I'm really excited for that one because I kind of need it myself for my kids. So it's a good exercise to say, like, hopefully this ends up helping me right away. But as a funny joke, then to refer back to only an engineer would spend twice as much money or time in that case, instead of just buying one for their kid. So, yeah. And then we're also working on some additional products coming up in the medical markets and things like that too. So
it's sort of an interesting question because I feel like when you ask, what are the potential applications of this thing, the answer is like anything.
There's a lot. I think we have narrowed down some of our focus. I think this is going to get to another question on here, which is
strengths and weaknesses.
There's embedded is just a huge field. Like depending on who you talk to, it's basically pretty much everything almost. And if you get down to it, but we focus on these more smarter network connected gateway-ish network or devices as opposed to like a not so smart sensor. It's very popular to have little microcontrollers on little sensors that you apply everywhere and they call home. And there's not much logic on them. That would not be a thing that we target with nerves. So the other side is as the embedded projects become way too complicated and involved, that's also beyond. That would be, like car, cell phone. Well, cell phones used to be a kind of embedded, but now I have no clue. They're just like personal computers to me now. So there's kind of like a middle ground of complexity where a lot of the features that Erlang really helps out with kind of are important. And that's where we've spent our time focusing.
Can you talk a little bit more about some of those, I guess, like either constraints or strengths, like what the strong areas to think about application-wise would be?
So I guess when you're coming down from, you have some device in mind, right?
Right.
And then you're looking for what technology you want to put on it. Sometimes it's easy. Like if you have a lot of networking involved with it and you have engineers who might know Elixir, be comfortable with that style of language, then you start looking very seriously at nerves because it has a lot of matches there. If your project just is completely dependent on a really small battery, for example, and like power management is going to be a major design focus, that's going to be something that you're going to be forced into a processor set that doesn't run nerves in the Erlang.
So like really small devices.
And there are a whole lot of these, right? It's like, this is, like I don't want to minimize the field. It's like a huge field of devices that fit this profile.
But like that would be like wearable devices just don't have.
This is where it gets all a gray area, right? It's like you look at the Apple Watch and that thing has an insane amount of computational power. But at the same time, there are other wearable devices that have almost none. So I don't think it's easy to just give these clear recommendations for what you want to go. It's kind of like you just have to look at everything individually. And if you, like sometimes you have things that are out of control when you do these projects, like how much you can actually spend on the engineering. And that's going to frustrate you some ways because Apple does some insane things. Like
how long before we get this thing on a rocket ship?
Sometimes if you're in a small company or you have a small development budget or whatever, you just have to face reality here that maybe some things that your Apple fits like insane amount of computational power in this little watch that might not be within your domain. So you might be effectively forced into a smaller processor and maybe a few less features.
But then to speak to that, like in that case, the smaller processor, the fewer features, there's two things that come to mind in this case. One, that thing's probably in its smaller processor and smaller feature set design going to have to go through some other thing to be able to get to the wider area network. And that's where we see a lot of installations with nerves.
Oh, yeah. That's effectively the SmartRent use cases. We use nerves and gateway devices. So just to back up, SmartRent, what we do is we retrofit apartment complexes, single-family homes, rental properties, basically with smart home features in a way that the property managers can share access to with their tenants in. So at any rate, when We have door locks, water sensors, thermostats, all kinds of stuff that goes in these installs. And they're all pretty low power devices with short radio ranges, and the Nerves devices gateway them up to the cloud and handle some stuff locally.
So that's a first avenue to it. And then if you think about that, you can kind of make correlations between language and complexity and like business logic. So if you consider the idea that as the complexity of the business logic that's needed at that stage increases, then such should your perspective on what higher level language you might want to use to approach said problem, because it might become something that's a little bit more difficult or a little bit more time consuming to do in really low level spaces. And at that level, since you need to do a heavier lift, you'll probably be reaching for something more powerful, at which point it would make more sense to be able to, or I should say, you'd have the capability to be able to take advantage of some of the higher level language technologies, like using Nerves, like using higher level languages like Erlang and Elixir.
Yeah, and time's certainly a component here. What's possible today, is going to be different from what's possible tomorrow. Right now it's the processing power that we can get in these little devices keeps on going up. So
I kind of want to return to this Apple Watch question, which is like, has anyone like jailbroken an Apple Watch and ran the beam on it? Do you even need to jailbreak it? I guess you could run it on like an app or something. Do we know about this? No?
I don't know.
Heard about this?
From what I've heard, I feel like if anyone has done that, it will be our next set of guests, and Connor will probably be the one that...
Yeah, that's a good point. Ask Connor that question. Because if there's some random usage of porting Nerves to some platform, he's the go-to person. Just to jump on some of these questions that I think are on the list that are kind of related. There's one about, is there support for an ESP32 or STM32 board, right? Or is this planned? And this comes up all the time, right? It's just like, what boards can you port Nerves to? So ESP32 and STM32 are microcontroller level boards. They don't have quite enough memory. Processing power sometimes looks like it actually might be okay, but really we can't run Linux on them. And the Nerves go-to is, can we boot a Linux kernel on it and have enough memory left over to comfortably run Beam? So those two particular processors aren't something that we're looking at. That's not to say that they're not looked at by someone else in the Erlang community. There's a project called Atom VM, which has not the Beam, but a different virtual machine that will run little Erlang programs on those processors. And the other half of this is, how do you go about porting applications or porting new boards? I think Justin was going to be talking about that a little bit, but the way that we all go about it is we copy paste from one of the open source ports that we have and start from there and move down. And the official Nerve systems, we keep pretty up to date and current, and they get a decent amount of use so that they form a good template. And then I think that if you're interested in a particular board, there are certainly a lot of unofficial ports out there that don't nearly get the kind of publicity. And that's everything ranging from like IMX6 to all kinds of random x86 embedded and maybe not so embedded x86 style boards. There's like a Lychee Pi port that's like this crazy small, or this really, really small ARM board that I think Justin? Oh yeah, Justin, you were the one that sent me those. So as a tangent, people send me hardware in the mail randomly. And that was one of the devices. So anyone who does this, I totally appreciate it. I cannot help myself but to open it up and do something with it. And I know that a few people...
PO box you want to give out?
Yeah, so definitely don't read between the lines. Frank loves receiving hardware randomly in the mail.
No.
This could be really bad.
This is the quarantine thing to do. Spend your time, building hardware and stuff.
Yeah,
send some boards.
Yeah, you were the person that sent that Lychee Pi over, and then Connor did the port, which had something he made some decision in there that looked clearly like it was to get my attention and to spend time on the board to fix it.
Wow, Frank, people love you, man. They're sending you gifts. We were just talking before the show that this poster behind you, Amos gave that to you. Like, they just love you, Frank. You just... Does anyone get as much like fan mail as Frank Hunleth? That's
I don't...
Fan mail is hardware. Send hardware.
Okay, guys.
I have fun with every piece. Yeah,
we have a shameless self-promotion and asks for the audience section of the show. So just hang in there. No. So Frank's actually doing a better job of sticking to the script than I am. We have a question here that I'm actually a little bit curious about, specifically around like Bluetooth low energy, because that was always a challenge for us at Pavlok back in the day. I'm curious, can you talk a little bit about integrating BLE on theirs?
So there was a swing that was taken at this early on from Very, before I was working at Very, by one of the engineers there, Dan Spofford.
One of the Daniels.
Yep. And I think there's actually, the number of Dans has diminished to now the Spoff nickname is no longer required, but just
Diminishing Dans?
So, yeah, Diminishing Dans.
No.
So, there was a project there that was done for, I think I'm allowed to talk about it, whatever, interstate batteries. So that project was shipping some Bluetooth, and it needed a minimal level of functionality for the Bluetooth stack. And so an effort was started to be able to try to make the Bluetooth spec approachable to engineers, to sort of make a system that was flexible, that could be extended to add more and more functionality. But from a contracting standpoint, as a consultancy, once the engagement ended and that customer was satisfied, Spoff had to go on and work on some other stuff. And so we've recently started to pivot a lot of that work that we do into a place where we want to still make it public, to be able to try to allow others to help push forward and at least have a place where they can get some reference on where others may have started. But it was tough because there's definitely a connotation. There's definitely a line that's drawn. Like when you say something is open source versus just saying that I made something public, right? Like saying that I made something open source means like, people interpret that as like, oh, this is forever going to be maintained by a community of people like yourselves, and I can hook onto this and take it and use it for my thing over and over again. And if I have problems, I will reach out to you and I will let you know that I have the problems, right? But it's tough because like you can't continue to manage everything. And so the point of all of this is to say that when it comes down to it, with stuff like Bluetooth LE, the spec, it's big, but it's not scary if you break it apart into its components. And much like anything else in software, if we just kind of follow some of the guides that are out there that got started in certain places, then it might help others be able to have a leg up on pushing it forward to implement the things that they need. And ultimately, in order for these things to progress, then people they need to actually have a need for it, instead of claiming that there's a lack of space for it. And that if somebody really needs it, it's not terribly difficult to make a contribution to push forward on it as well. Somebody just needs to have a project.
So one project that I've seen that Michael Reese was doing something with BLE and a golf cart, I think. So yeah, and I just remember him saying that on Twitter, like the Bluetooth spec is like 1,300 pages long or something obscene.
Yeah, I suspect it might even be longer than that. That thing's a behemoth.
With the amendment,
the part that's important for this is much smaller. Bluetooth is like completely overwhelming when you look at it, I think, at first blush. And then there are a couple pieces that are much, much, much more important than others when it comes to BLE. And I think that I did a little bit of rage coding, I don't know, a couple months ago. Well, at least trying it out to see where things last on Herald, because we were getting so many questions, and neither Justin or I, our companies don't use, well, your company used Bluetooth and shipped the product with Herald on it, and Herald works for that use case. It just doesn't happen to be a use case that most people coming to Herald are looking for. They want something that they can connect to a phone, I think, or at least on that level.
I'm sorry, did you say rage coding?
It's a popular form of coding. You're not familiar?
The only form of coding, actually. The only form I'm familiar with. No, I'm just kidding.
Yeah. So I wrote up some notes. I'm not completely sure they're 100% accurate, but I think that they're good enough to like get something a little bit started. And I'm hoping to encourage people, like, if you decide to put a little bit of time on this Bluetooth problem, maybe just put like a little comment on my gist or something. You can find the community that's been interested in nerves and Bluetooth in the past on the Elixir Lang Slack and the Nerves Bluetooth channel.
Mm-hmm. And we can link to it in the show notes.
Yeah. And there'll be a link to the gist that was made off of it. And with the gist, I have it so you just download a firmware image, plug it into a Raspberry Pi Zero, connect it up to your laptop, and you can do all your development with Herald on your laptop. You don't have to be creating Nerves firmware at all. You can just go Herald straight through the Bluetooth chip on the Raspberry Pi Zero W. So if you make any progress, I hope that people can put like comments there, because I know at some point someone's going to be like, I have a business need, or I have some hobby project or something that I really want to push across the finish line, and be willing to like get this thing over that hump that it's currently at. And we'll eventually get there. I think
I mean, this
Yes.
if anybody is out there that's interested in doing Bluetooth, I think joining that channel would be a great way to be able to say hi to each other and start vocalizing that community. And I want to use this as a means of touching on the Nerves keyboard people. Frank, you know more about this. But it's like they were a group of people that were passionate about a thing that had a use case that required some technologies, and they advanced parts of the stack. They made contributions back. And so as a group in their spare time, they ended up being able to all work together on a project that they're building together. And that's what it would need for Bluetooth. But Frank, talk about the keyboard.
Oh, the keyboard's awesome. And just talking about sending hardware, I have a package that's in the mail, and it currently says it's going to get to my house on Monday. And it has their keyboard. I'm so excited. So
somebody's building Nerves keyboard with like a clickety-clack keyboard with Nerves.
Yeah, so
that's amazing.
So the interesting part that they went about solving that actually took a little bit of time was, how do you turn a Nerves device into something that you can plug into your PC so it shows up as a keyboard, right? I mean, this is a Linux thing. We've supported this kind of on little bits and pieces in Nerves. It's not something that a lot of us do all the time. It's one of these things that's just a little complicated enough that you'd have to put work in, and they did. And so it's really cool to see this.
Is this something we can do as well?
Oh, yeah. They have a lot of stuff. I know on the Elixir Line Slack, it's Nerves-keyboard, but I think they have some web pages, and GitHub pointed off that too, that if you don't see anything quickly there, I'll dig into. They're a friendly group. I think it's the Elixir meetup in Seattle. I think that's
I'm finding a lot of carpal tunnel things, plus ElixirConf EU, and then an empty repo. I think it's all that's coming up right now.
Well, after this call, I'll make sure that you guys have good links.
Yeah.
So we want to get to a few more of these questions. One that we tagged as being an interesting question was, how can you extend the functionality of a file system on Nerves?
Oh, right. This is, I think there's some questions there. There are multiple directions that you can extend. So this one, I have the feeling like there might be some intent, but I'm not quite sure what it is. So I'll just talk about a couple things.
Sure.
Unless, Justin, you figured this out. So on Nerves, we control the whole all the file systems that run on the device, right? So there's a program we use called FWUp, which there's a configuration for it, which says where your partitions are. So it's like if you're a Raspberry Pi, you have a micro SD card, and it gets divvied up based on that configuration. We have a prescribed configuration for our micro SD cards. If you're building a product, you might have something like eMMC, in which case you might want to modify things a little bit. Two main routes that people go: master boot record or GPT partitions. Most of the official stuff is master boot record, so 4 partitions. So extending it is 4 partitions doesn't give you much room to extend. You might be able to add one more partition and format another file system on it with, contain some provisioning material, for example. So maybe I skipped over. The partitions that we currently have are required for the processor, like a boot partition that's required that we can't change. Another partition for the root file system, which is where we keep Linux and we keep your Erlang application, your release, and all that stuff. It's all read-only. Those people might be familiar with the AB partition swaps, the read-only partition swaps that we do for controlling which firmware build of your program that the device runs. And then the final partition that we ship with is the application data partition. So you can just write everything, whatever you want, whatever your application wants to write, keep a database there, whatever. That's the one that I sense may be of interest to this question. So right now, most of our platforms are ext4 for that one. It's a typical Linux file system. On first boot, it gets expanded. In our default configurations, it will expand to the size of your drive, and then it'll get reformatted. If for some reason it doesn't get expanded, or you have it force set to something low, then expanding it later on is kind of a trick. It's just like if you were to change the size of your hard drive partitions on your own laptop. It's something that we don't really encourage, but people do, and it ends up being similar to what you do on a Linux PC. Okay, so that's part of it. And then when Justin and I were talking about, there's another facet of this that people could be asking about is the root file system's read-only. That we know is kind of an annoyance, right? You just want to change one file. Like, why do I have to upload a whole new firmware? Oh, there are many good reasons for doing that in production, right? Production having a known set of bits for the root file system. But just ignore that for now. I'm debugging. I just want to change a few files. How do I do that? We say you can't, right? But there's a concept called overlay file systems. And early on in the Nerves project, we had this feature. And I almost think that we might even be bringing this back for development because this use case is kind of convenient to where you might want to mark or modify something. So the overlay file system idea is you have the base file system, which would be this read-only one. You overlay a writable one. Whenever anything makes a call into Linux to get a file off the drive, it'll consult your writable one, which could be an in-memory one. I mean, so that just clears itself on reboot, which might be completely fine. It's probably worth discussing why we moved away from this. So when we first had it on there, it turned out that that overlay file systems were a little flaky. And this is pre-Docker days. I mean, I guess Docker was around, but Docker, in my impression, fleshed out like every bug possible that you could have in an overlay file system. So I think it's worth the experiment. Again, I got to imagine it working pretty well now. So I think that's one just waiting for someone just to push that one over the edge. I think it's like tweaking a few configurations and playing around with it a little bit to make sure that you're happy and then sharing the result. We can get it in.
And I think there's value in shining light on the fact that you mentioned that bringing that back would be good for development purposes, because the reality is that some of the pain that we end up rubbing up against that might require a little extra detail or slow down the development experience a little bit with Nerves is that the product you build in Nerves excels in the production environment. It's like really immutable. It's really strong. It's really explicitly like there. It's easy to reason about. But that's because you're just sort of packaging just what you need to be able to make that thing work, which is good because it protects you from everything that you don't need, that you may have packaged with like a full desktop system, like Raspbian. However, Raspbian has its merits in debugging or testing and things like that, where you can much more quickly iterate over things in Raspbian, which is like Raspberry Pi's form of Debian, which is just like desktop Linux on Raspberry Pi, right? And that's because in that case, like Debian and Raspbian, they're going to come with all of the bells and whistles and lights turned on and let you be able to just kind of play around and like at runtime do stuff. But that's not a very good production environment to ship, right? So it's like some of this stuff you can get away with by, and I'm going to use this as an excuse to answer one of the other questions. Some of this stuff you can use to get away with enhancing your development environment. Like there's different ways to be able to go about this. Like trying to do as much as possible on your host, for example, is a great way to be able to increase the performance of your development experience. A lot of your business logic, if you can decouple it from, like you can create quality contracts in Elixir to decouple all of the hardware specific bits. Like let's say you need to talk to a sensor. Well, if you can make an interface that mocks that so that your tests can still exercise what the business logic is that you're writing for how to handle that sensor data or communicate that sensor data to something else, can really speed up your development experience, because then you don't have to push to the device every time you need to just make sure that you can send some data to the cloud, right? And as such, we found that it's more and more beneficial to be able to try to structure your logic encapsulated inside of OTP applications and not necessarily just modules. And that the place where Nerves is going to produce its output that's great for production, you're going to want to try to be able to keep that as like the contractual glue layer between like your business logic and your hardware front, right? And from there, we recommend the poncho style approach of just decorating the environment, like pushing the rest of the requirements out to other external OTP applications and including them as dependencies, so that they can be integrated and tested as smaller components and on their own wouldn't necessarily be burdened by the inclusion alongside of all of this very specific like hardware integrated bits.
Yeah, I think it's interesting to see how the project has changed over the years, because early on, we were like all in for hooking up Erlang distribution and setting up hot updates and pushing your releases over Erlang distribution, just iterating that way. And then as we started getting a little bit more experience, we started finding that it was more effective to pull logic out that could be fully testable in isolation and use the main Nerves project as more of the glue. And that it helped. I want to be careful because I actually kind of think that the other approach is cool and wouldn't mind doing a little bit more about that. But it is just interesting how our focus is the past few years went very much to the poncho style setup and minimal code.
We're almost out of time, and we have two more questions we want to get to. Eric, do you want to kick it off, and then I'll ask you a little bit about like the future and what's next?
Yeah, so I guess sort of along these lines, we had someone asking a question about Nerves and deploying with Nerves Hub. They have a config target EXS with Wi-Fi config, and they're building firmware. Like, how do you deploy that to different devices that will have different Wi-Fi configs and all that?
Right. Yeah, I'll take part of this. So the question is, how do you deploy? Do you have some specific settings that just depend on wherever the thing gets installed? And if you're using Nerves just for a hobby project, build it into the firmware. My device's firmware is hard-coded to my own home Wi-Fi access point. Totally okay, right? That's like easy, quick setup. But it's just not something that you can ever deploy any number of devices with. There's a project called VintageNet Wizard. So the idea is that you start your project with an empty Wi-Fi config, right? You wouldn't know anyway what to put in that config. The VintageNet Wizard is a project that knows how to configure a Wi-Fi module to go into AP mode, and then it will broadcast. It has a little web server that it runs. You log into it over your cell phone or a laptop, and it will tell you what Wi-Fi access points it sees, and you just pick one and set it, and then it updates the config. So you can do that. I think the end result is if you don't want to use that, you could imagine coding something up. It's basically a one-liner to set the configuration, and VintageNet will persist it for you for the next boot. So somehow you have to get that VintageNet config line run, whether it's through the wizard or through some other mechanism. Maybe your device has a little UI on it. I don't know. That's the place to go. I think the other thing to say here is in the devices I build, we have manufacturing stuff where we can provision stuff in. We also have a site prep stuff where we can set stuff in before things go out. So if you have one of those stages, then the way we do it, we have a dedicated PC that runs a little piece of software that anyone can plug a device into. It will detect it. It might know like whatever credentials or whatever it needs to put on there, or the settings. Like if you know where you're going to install these things and it has a particular Wi-Fi access point at that location, you could pre-configure it there at that step. I don't know, Justin, do you want to add anything there?
Yeah, no, I think after that, it's a matter of the fact that connecting to a Wi-Fi network is an implementation detail of projects. So therefore, I default to the fact that that could be configured from any external domain. And so therefore, because it's ambiguous on where, our best effort at being able to help support that is with VintageNet Wizard, which has been a wonderful effort. But other than that, it's up to your business details of your application on where you might capture that information. Like you might be an enterprise account, you're deploying it to a warehouse and the Wi-Fi IDs, or you want to geographically distribute, them as well. So just query whatever central server you have and traffic that information at runtime.
I want to get one more question in, and also please use this time to plug your own projects, your companies, whatever you want. But we want to know about what the future of Nerves looks like, and also if Nerves Hub is ever going to get a facelift.
Nerves Hub is getting a facelift.
Spoiler, I have screens. So as the plug port, I've since the beginning of the year started work at Very, and we have been working to build and produce IoT products for all types of different domains, and we have a wide variety of experience from data scientists, embedded engineering. We do hardware designs. We also can do mechanical manufacturing too. So we can cover the gamut for all of the IoT space, and we've been really interested in the usability of Nerves Hub from the web experience perspective. So we've decided to spend a lot of time and energy and focus on enhancing that to be able to make it as best as we can. I saw some of the new screens. They look gorgeous. As you can see from the nerves-project.org site, that we've undergone a little bit of a facelift recently, and that with the help of Very, we're also trying to be able to help promote in this stage of Nerves a lot of the adoption. And this sort of leads into then answer the last bit of the question, which is like what the future would be like. Like currently the roadmap for us is that a while back we shipped Nerves 1.0, and then we started focusing on a lot of the runtime components. Frank and members at SmartRent, as he'll talk about soon, they've been working to push forward a lot of the polish on a lot of the stack to be able to add robustness to the system and shore things up more and more. And so from my perspective as well, for the future, I'm looking to be able to promote adoption as much as possible, which involves trying to be able to make ourselves more approachable to the people who are interested in implementing Nerves and their projects from the web perspectives. And so we've had help with various marketing departments there to be able to create new web domains, new places to be able to digest some of the information that is the elephant of what you can do in the IoT space, and just try to be able to install it in as many places as possible so that we can continue to learn from the experience, that I can continue to learn as well from the experience of adoption, what things need to be able to get added in and make it better. And so from our company, we've been making some work towards whatever we might be focusing on or experiencing during that time, we'll try to be able to open source and work with the community to like push that work out there.
Awesome. Final word with Frank.
Oh, wow. So I had a couple things, and I guess I'm going to abuse my time slightly, but okay. I wanted to point something really important about what's happening with Nerves Hub. Nerves Hub is going from this open source, well, it's going to stay open source, so I'm not saying that. It's going from an open source community-sponsored project to more commercialized so they can go long-term. Like, this is really important to have a meaningful resource supporting Nerves Hub firmware updates. So Very is taking the lead on this chapter of Nerves Hub's life, which is going to keep it going long term, right? This is hugely important for us as a project because it's an expensive service for us to maintain, certainly as Nerves starts getting more and more users. And we want to be able to supply stuff like some uptime guarantees, which Nerves Hub's amazingly stable as it is. And, it doesn't use much of Justin's and my time for going down, but still, that's not something that we can count on all the time. There's upkeep for sure. So I really want to spend some time thanking our open collective sponsors, because our group, Nerves, we have this open collective. People just sponsor us, and this has just been awesome. This has let us pay AWS fees for getting Nerves Hub going, and this is going to make a transition. So the open collective money is going to be going more towards core Nerves stuff in a bit, but this is where we want things to go, right? We want to be able to make these things long-term viable. So I guess just the other thing, anyone worried about Nerves Hub free access going away for hobby, personal use, that's not happening. So that's hugely important to Justin and me. So that's always going to be a resource for our community. It's just going to be, I think, in more long-term hands. So let's see. Got my piece on that part.
You want to shamelessly or like plug anything?
I would plug SmartRent. SmartRent has been an awesome supporter of this project. I can't thank them enough. I mean, right? So the SmartRent funding that's been going has been paying for my time and others. And the company as a whole has let us open source just a ton, right? It's been very easy, right? You're not going to see a lot of business logic and other thing that you wouldn't expect to be open source from any company, but they have been very flexible with the people working on Nerves and Elixir-related projects to get them in the open source domain. And I think where you probably may see and hopefully start seeing more of is in the polish on some of the networking components, for example, with VintageNet to keep the solid link up. You can see our Grizzly project, which is a Z-Wave client library, which is pretty full featured and I think easier to use than the default Z-Wave stuff that you get from the people making it. So that's fully open source. Not our stuff doing any of the application logic, but there is an awful lot to Grizzly that's open source that you can do smart home-like things on. So that's what's coming from us. And we're hiring, sadly, not in my group, but if you are in the market, please check our website.
I should say the same. We're hiring as well, yeah.
SmartRent and Very, both really great organizations and huge contributors to the Elixir ecosystem. So check them out. Frank Hunleth and Justin Schneck, thank you so much for coming on the show again, guys.
Thanks for having us.
Thanks, Justin. Thanks, Eric.
That's it for part one of our special Elixir Wizards Dojo recorded live earlier this summer. We wanted to thank today's guests, Frank Hunleth and Justin Schneck, of course, our friends at ElixirConf Japan, who invited us to put together this special series, and all of the Nerves community members in Japan and around the world who sent in their questions for us to ask Frank and Justin. Special thanks as well to a friend of the show, Paige Finkelstein, who translated our intro and outro and delivered those in Japanese for our listeners in Japan. Once again, I'm Justice Epen, and my co-host is Eric Ostrich. Elixir Wizards is a Smart Logic podcast. Here at Smart Logic, we're always looking to take on new projects building web apps in Elixir, Rails, React, React Native, and infrastructure projects using Kubernetes. We'd love to hear from you if you have a project we could help you with. Don't forget to hit that subscribe button on your favorite podcast player, and please leave us a review on the iTunes podcast store and on Stitcher. You can find us on Instagram and Twitter and Facebook, so add us on all of those. You can find me personally at Justice Epen and Eric at Eric Ostrich. And join us again next time on Elixir Wizards for part 2 of the Elixir Wizards Dojo on Nerves with Connor Rigby and Todd Rezadek.